introduction. Good evening. Today we're exploring how electricity can be generated using magnetism, a phenomenon explained by Faraday's law of induction, discovered by Michael Faraday himself.
Faraday's law tells us that the induced voltage depends on how quickly magnetic flux changes over time. This principle is used in generators, power plants, and many modern technologies.
What was your prediction?
We predicted that increasing the magnetic field by 20% would increase the induced voltage by approximately 20%, since EMF is directly proportional to magnetic flux change. The materials we used coils, magnets, voltage and magnet field sensors, a clamp stand, cushion box, and capstone software to collect and analyze data. Procedure. To ensure a fair test, we drop magnets from the same height, use the same orientation each time, kept all variables constant except magnetic field. Each magnet was passed through the coil 5 times, and we averaged the peak EMF values. So this is going to be the data and the analysis.
What trends did you observe?
So the percent change in EMF closely matched the percent change in magnetic field. Both increased in the same direction. Differences were typically under 5%, which is negligible.
Would you say that this supports your prediction?
Yes, it supports our direct proportional relationship.
How much it costs, for which ones, cocktails, where we can go in.
1.6.
Yeah,
Last one.
Dang, this is so like. And then
1.6.
we're gonna do like 2 custom drinks. Oh, okay, no, you couldn't. I feel like
Okay,
this
graph
is like
looks good.
you drink a margarita, you know? Oh, I'll put down some red wine on fire. He's a diva, but Grey Goose fake makes sense. I feel like martini. This martini. Where's my You're giving right? Not really.
A new variable, so we did change the speed of the magnet by increasing the drop height. This increased the rate of change of flux and successfully increased EMF by about 20%.
This is the conclusion. Let's go through the key conclusion questions. Which one is greater? Percent change in magnetic field or percent change in EMF?
They were approximately equal. Any small difference under 5% is considered negligible and likely due to experimental error.
Do all values change in the same direction?
Yes, when the magnetic field increased, the induced EMF also increased. This confirms a direct relationship.
So let's talk about the ratios. Are the ratio changes the same?
Yes, the ratio change was approximately 1, meaning both quantities changed proportionally.
Do these results support your original prediction? If so, please tell us why.
Yes, they support our prediction because the experimental data shows that EMF increases proportionally with magnetic field. consistent with Faraday's law.
What do your percent differences errors mean?
So the small percent differences indicate our measurements were accurate and reliable. They show how close our experimental values were to the expected relationship.
What caused these errors?
So possible sources include slight variation in drop height, inconsistent magnet alignment, sensor precision limitations, and human reaction time.
Why do these errors matter?
They affect precision but not overall trend. Understanding them helps improve experimental design and accuracy in future trials.
All right, Jaren, what did you learn from this experiment?
So I would say my group learned that changing magnetic field strength directly affects induced voltage. Increasing speed also increases EMF, and Faraday's law accurately predicts real-world electromagnetic behavior.
Thank you.
Thank you.
Credits. I'm Hannah Macias, the journalist.
I'm Jaren Canary, and I was the scientist. And our other team members, Damien, Remington, and Adam, helped with the experiment and the PowerPoint. That's it.
Thank you, and good night.